Okay, so first let me take the syllabus. Okay, yes. So we have been discussing about Git last day. Okay, so we have discussed about what is Git and how can we create a repository in GitHub, and then how to push something on the repository. And I have talked about the importance of Git based portfolio for getting I mean getting much attention from the community. For example, if you have good amount of project on your GitHub, then you will get a lot of visibility from the community as well from industry, and then there is a there is a good chance for hiring. So that's what we have discussed last day, and there are some more topics that need to cover in Git. Actually, Git is a very vast topic, so I just picked few topics from Git, and then I'm discussing it. Okay, so after covering this topic, we will be jumping into Docker, which is again one more tool that we are using to deploy your application, ROS based application. Okay, so you can use Docker for deploying any kind of application, maybe a web application, then yeah, any kind of application you can deploy. So we will I will give a basic overview of Docker, and we'll give some idea how to get started with Docker, and what are the main components, and why Docker is important when we learn ROS. Okay, so these are the things. So let me start with Git first. Okay, so I hope you have an idea about Git from yesterday's session. Maybe I can give an abstract of Git again. So yesterday what we have done was I have my GitHub account here. So this is the RoboAcademy account. This is my profile, and what I did was I have created a sample or dummy repository called ROS object detection. Okay, and then I have created the name, and the repository is private. Okay, and I have given a description. Then this is a readme. Then what I did was I have shown how to clone this repository. Okay, how to clone this repository through HTTPS protocol and SSH protocol. Okay, in HTTPS I talked about the personal tokens. Okay, that is available in the settings. You can generate it, okay, from the developer setting, personal access tokens. Okay, I also mentioned about the importance of SSH keys while working with SSH. Okay, while working with the the SSH mode, which is like if you use the SSH based link from here, okay, then you it will be better to add the SSH key, public key, to the repository. Okay, so this is the option to add your SSH key, public key, to the Git repository. Okay, then you can push the repository without having any password. Okay, so these all are the things that we have discussed yesterday, and today I'm going to introduce a new thing in Git. Okay, it's called Git branches. Okay, Git branches. So let me first show you a diagram. Okay, then you will get a good understanding. So there is a terminology called branches in Git. Okay, so how it is working is that imagine you are creating a project. You are working on a project called ROS object detection. Okay, and again there are 5-member team. It's a 5-member team, and each member, okay, is working on different features, okay, different features. And one guy may be working on object detection, one guy may be working on motion detection, etc., etc. So Git is having a feature called Git branches, okay, Git branches. So by default, Git is having a main branch, okay, main branch called, the name of the main branch is main itself, okay. So if you just check this repository, okay, if you push the things into the main branch, it will be going to the main branch itself, okay. But you can create different branches, okay, you can create any number of branches, okay. So why we have to create different branches? I can say like, if you're working on adding a feature into an existing code, okay, then you have to spin off from the main branch to create another branch called feature 1. You can name the branch, okay, you can give a name like feature 1, feature 2, or something like that. So you can create a copy of the main branch into the feature branch, okay, feature branch, and you can work on the feature branch instead of the main branch, okay. Then after working on the feature branch, once you completed your feature, then you can merge this feature into the main branch, okay. So so why we are doing this? Because we are considering the main as the main branch, which is having the stable code, stable version of the software. So if you take, for example, the object detection, the main branch should contain the stable version. If I take another, maybe I can take GitHub OpenCV. So if you take the OpenCV repository, you can find the list of branches. You can see it here. There are 6 branches. So if you click here, you can find there is a master branch, okay. Actually, there was a controversy regarding this master branch. Actually, the main branch that I mentioned here was the master branch before. The name of the main branch was master before, but there was some issues with master and slave terminology. So GitHub actually renamed the master into main, okay. So the master branch, you can name it as master or main, but by default, I think Git is now renaming the master into main, okay. So you can see the active branches now is master. Then there are like this much of branches, okay. Then the default branch is 4.x, okay. So this is the latest one. But if you switch to master, which is having the stable one, stable code, okay. So this is the branch that that is having new development happening, okay. So you can actually select the default branch, but the intention of the master branch or main branch is that whenever we add a feature and after testing that feature, we will merge that to the master branch, okay. So there is a different procedure, like whenever you create a branch called feature 1, for example, and after developing this feature, you will create a thing called pull request, okay. Pull request, meaning it simply means you are ready to merge your feature into the main branch, okay. So this pull request or the merge request, okay, it will be checked by the maintainers or developers, okay. For example, I can create a pull request. I can show you that, okay. I can create a pull request from the feature 1 branch, and then the pull request will be checked, okay. So the team will check whether this pull request is okay or not. If this pull request is okay, then what happening is that the feature 1 branch will be merged to the main branch, okay. So the feature that you have developed is merged into the main branch, okay. Then after that, maybe you can keep the feature 1 branch or you can delete it, Okay, so that's how we can create branches, and you can do the branching in any ways. I mean, there are multiple ways. Here you can see from the feature 1 branch, we are creating the feature 2 branch. Okay, so the feature 2 branch, after completing it, will create a pull request to feature 1 branch. Then the feature 1 branch will merge feature 2 to feature 1. Then after feature 1, it will merge to the main code. Okay, so the structure of the Git repository is there will be a main branch and there will be feature branch. Okay, and you are working on the features, and then after testing and everything, you will be raising a pull request. Okay, then after raising the pull request, the maintainers will check it. Okay, they will inspect your pull request whether it is good or not. Then if the pull request is good, then it will be merged into the main branch. Okay, so this is the method that you're gonna use for doing a open source contribution. Okay, so like maybe I can mention that after this. So for example, if you want to give a contribution to OpenCV, first what you have to do is you have to create a copy of OpenCV in your profile. Okay, so for example, there is an option called fork in the GitHub. So if I press fork here, okay, then what happening is that a copy of the OpenCV project can be seen in your repository or in your Git profile. Okay, so currently the OpenCV is available, the repository is available here. You can see the complete project is available here. Okay, then what you have to do is you have to like create a branch here. Okay, then you have to like add your feature. Okay, then give a pull request from this repository to the actual repository. Okay, I will show you that. Okay, so I'm just saying these branching, then forking, all can be used for giving a open source contribution. Okay, which is one of the objective of this course. Okay, so first maybe I can start with the branching. Okay, then I can show you how the forking is done, then how to create a pull request, then how to merge it, all those stuff. Okay, so let me close this. Okay, just a sec. Okay, just a second. Let me just take the list of commands here. Branches. Okay. So this is our code. This is our repository, and we have this repository on here. Okay, so this is the local working copy that we have. Okay, and yeah, so if you have this repository in front of you, okay, then what you have to do is, I mean, if you have your own repository, no problem, you can enter a command called git branch. Okay, git branch. So if you do that, you can see the current branch is main. Okay, it's a main branch. Okay, so we know that the current branch is main, and now I just want to create a new branch for adding a feature. Okay, for adding a feature. So what I have to do is I have to check out a feature branch. Okay, feature 1. Okay, so what happening is that it will create a branch called feature 1 from the main branch. Okay, basically the feature 1 will be a copy of the main branch. Okay, but it's a different branch. So I'm just checking out feature 1 means we are switching into feature 1 branch. Okay, just a second. git checkout. Let me check. Feature 1 did not match any files to git. Just a second. Okay, git checkout B. Okay, so there is a one argument missing. Maybe I can just paste this command. So if you want to create a new branch, then you have to use an argument called -b. Okay, -b will be creating this branch, new branch. But if there is an existing branch, then you can only use checkout. Okay, so if you give command called git branch, then you can find currently you are in the feature 1 branch. Okay, so if you do any modification on your code, it will be only changing in the feature 1 branch, not in the main branch. So your main branch is safe. Okay, so I can explain it again. Basically, we are creating a new branch using this command. Okay, so we have to use git checkout. Checkout means we are checking out to the new branch, and -b means you are going to create a branch called feature 1. Okay, so after that, if you just do the git branch, then you can see the current branch that you are in is feature 1. Okay, and if you want to check out to the main branch, then you can use git checkout space main. Okay, it's very difficult to remember all these command. Okay, maybe after practicing you will remember the main commands. Even I am not remembering all the command. Maybe I will refer in Google or something, but I know the workflow, what to be done. Okay, so if I do the git checkout main, then you can see switch to the branch main. Okay, then if you do the git branch, you can find you switch into main. Okay, so I'm again checking to feature 1, and you can just do the ls, and you can find this is actually a copy of the main branch. Okay, and now you are changing it. So what I'm doing is I'm just adding a feature here. Okay, added a new feature. Okay, so what we have done was we have created a new branch, and in the new branch we have changed the object detect.py. Okay, and inside that I just added a new feature. Okay, so now if you do git status, okay, git status, it's again another command. Okay, git status. So maybe I can send the link as well that I am referring. So if I enter the git status, then you can find a file is modified. Okay, and in order to commit, you can use the git add, then commit commands. Okay, so and if you enter git diff, okay, git diff, okay, git status, git diff means the difference actually. Okay, difference between the what are the difference happening after the modification. So you can see this is the difference. There are some spaces, there is a equal symbol, then there is some strings. Okay, these are the difference. Okay, and now what we are doing is we are committing it. Committing means we are adding to the local repository. Okay, so first we are adding it. So you can simply just add the object detect.py because there is no other files changed. Okay, otherwise you can just use this one. Okay, and then you can commit it with a message. Okay, in order to give the message, you can mention -m, then added new feature in object detection. Okay, committed, right? Then what I'm doing is I'm pushing this code to which branch? Not in the main branch, but in the feature branch. Okay, Okay, yesterday, if you remember, we have pushed the code into the main branch. Okay, but currently what we are doing is we created a new branch. In the branch we have added some features, then we are pushing into the new branch. Okay, so this branch will be visible in the GitHub. Okay, if you do this, let's see what happened. Okay, so you can see here it actually pushed all the code, and here you can see create a pull request for feature 1 on GitHub by visiting this one. Okay, so they are saying if you want to create a pull request, okay, then you can use this link. Okay, I mentioned what is a pull request is. Maybe I can show you that. If you just visit your repository, you can find the feature branch is here. Okay, the feature branch is here, and if you just switch into the feature branch, you can switch here. Okay, you can simply switch here, and if you just open the object detect.py, you can find this one, added a new feature. Okay, but if you switch into the main branch, then the content is the old one. Okay, so in the feature 1 we have added a new feature. Okay, and what is the next step? In order to add this feature into the main branch, you have to create a pull request. Okay, so after doing the modification, make sure you tested that feature. Okay, you tested the feature, then only you can give the pull request. Okay, so make sure you have did the basic work before the pull request, and then you can create the pull request here. Okay, you can do it in the command line as well, but maybe I can do it via GitHub. Okay, so I am also checking how to create the pull request from the command line, but that is fine. You can use this link. Okay, so just press this button, compare and pull request. Okay, or you can click here. Okay, you can click here. So here you can also create a new pull request, and then you can create it. So first I can show you this one. Okay, feature 1, compare and pull request. So what is happening here? We are we have a feature called feature 1, which is actually going to merge to the main branch. Okay, and this is a request for that. Okay, so some developers actually created a feature. For example, me actually created a feature, and I'm just typing, hey, I added a new feature. Okay, new feature, and face detection is included. Face detection is included. Then motion detection is working. Need to fix some bugs or something like that. Okay, so when you create the pull request, the GitHub is saying these two branches are able to merge. Okay, so GitHub is automatically checking if there is any clashes between these two branches. Okay, if there is any clashes, or if there is any problem with the merging, a difficulty in merging, then it will show like there is some problem with the merging. You have to fix that first, then only you can merge. Okay, so currently it can able to merge, and now you can, and this is a message to for reviewing. Okay, so like if you are a 5-member team, then you can just give these pull requests, you can assign these pull requests to the existing developers, and they will review it. Okay, so that you can give name here. For example, that guy should be a collaborator for this project. Okay, so then you can just add the reviewer, and then what happening is that the merge request will be, the pull request will be only accepted if the review is successful. Okay, so now I am creating a pull request. Okay, so this is the pull request. Okay, so if you assigned or if you added reviewers, they will actually do this pull request after verifying it. Okay, so if you create a pull request, you can check what are the changes that developer did on the feature one branch. You can see there is a one commit, and the commit is added new feature in object detection, and you can see this is the change that the developer done on the code. Okay, so this is the new feature he done. Okay, and what are the files change? The object detection change, and from this pull request you can find all the things, like you will get the description, you will see the changes that the developer done and all these things. And if this is okay for the reviewer, then what he will do is he will merge the pull request and confirm it. Okay, and you can find the pull request successfully merged and closed. Okay, so now the pull request is successfully merged. Okay, so now you can find in the main branch, if you checked, we have the feature. Okay, we have the feature, meaning the feature one is added to the main branch. Okay, and if you want to so currently you can find the two branches are there, right? So if you want to like delete this branch after the merging, you can do here. Okay, you can just delete it. Okay, so if you just refresh, you can able to find there is only the main branch. Okay, so this is the workflow that we are using in order to fix a bug in a software, or add a feature into the repository. Okay, so branching is important. Okay, branching is one of the key things, and the good branching will be always I mean, there are different branching strategies that we are using. Okay, so if you do the branching in a proper manner, then you can effectively add the features into the main branch. Okay, and this main branch code will be going to the production. Okay, so this main branch will be going to the production server and it will be executing. Okay, so the main branch is very I mean very sensitive. Okay, so once the main branch is updated, then this will be updated on the production. Okay, and there is another thing called CI/CD. Okay, it's called continuous integration, which is a part of DevOps. I think you have seen the DevOps yesterday, right? Let me show you that. Okay, so the DevOps, it's basically like how I think this is a better diagram for DevOps. Yes, so this is actually DevOps. I think this image will be useful for you, and also this link. Okay, so you can see for a software development, it's happening from where? Actually from here, the code, I mean plan, from here, the plan, code, build, test, release, deploy, operate, monitor, again plan. Okay, so this is actually happening from the software development cycle, starting from the plan. Okay, and in coding we are using Git, Jira. Jira is for like planning. Okay, Git is for version control, and for developing code you can use some IDEs like Eclipse. Okay, Eclipse is an IDE. So these all are the tools we can use in the coding. And for building, you can use like Gradle. I mean, if you work with Android Studio, then Gradle is one of the build tool to build the project. Okay, so for building and testing, we have JUnit. I mean, there are different testing framework, And for releasing, we have Jenkins. There are some tools, and for deploying, there are Ansible. So there are a lot of demands for these platforms. I mean framework. Mainly in IT companies, there are a lot of expert in Puppet, Ansible. Okay. Then Monitor, Splunk. I have heard about Splunk from one of my IT friend. So he's working on Splunk, Ansible, and all. So these all are the part of DevOps that that most of the companies using. So Git is actually in the coding section. Okay, so I think you got an understanding where we are using Git and the importance of Git in DevOps. Okay, so we are using the Git code for building, okay, the main branch obviously, and then we'll do test, release, deploy, operate, and all this stuff. Okay, so that is done, and now let me check if there is anything I need to check. And also, like for Git, there are multiple commands. There are a lot of commands that we need to learn, but I am only like mentioning the important one. Okay. Okay, so now we have seen the pull request, right? Pull request, we have seen how to create a branch, then how to raise a pull request, then how to merge it. Okay, so now the thing is that the main branch, okay, main branch actually updated, right? The main branch got updated. So what about the local repository? I mean, the main branch in the server got updated, okay, but what about the local repository? We have the local repository, right? So is that updated? No, right? Because everything, all the merging and pull requests happened on the server, but not in the local repository. So in order to like update your local repository from the online repository, you can use git pull. Okay, git pull. Okay, so the git pull, what it will does is that it will update the online repository in the local repository. Okay, so if you check, you can find the feature branch that is not deleted. Okay, but if you just check out to main, okay, if you check out to main, you can see, oh, let me check. If you check out to main, you can see your branch is behind 2 commits. Okay, that means we have merged the code. Okay, we have merged the code, and if we just do the git pull, then it will update the current branch. Current branch was feature 1. Okay, so that will be updated. And if you check out to main and if you do the git pull, then the main branch will be updated. You can see the main branch now got updated, and you can see the object detect.py got updated. So now if you check the object detect, you can find we got the new feature in the main branch. And I have a confusion with the feature 1 because it actually deleted in the online. Okay, it should be deleted offline. Yeah, I think yeah, I need to check that, because if I check out to the feature 1 branch, which is not existing actually in the online, let me check. Yeah, so if you do the pull, it's saying there is no feature 1 branch. Okay, so I think we have to manually delete it, but I need to check. Okay, I need to check. But the point is that if you do some pull request in the online repository, if you merge it, then you have to update the local repository by doing the git pull. Okay, then only the online repository and offline repository will be in sync. Okay, you have to use the git pull. Okay, So these are the main thing that you have to care about. Okay, these are the main stuff. And there are commands to delete the branch. There are a lot of commands to do the basic stuff like renaming the branch, pushing, committing. I think you guys can use this tutorial. Okay, it's very straightforward, and I will be mentioning some more video tutorial for learning Git. Okay, so I think we have discussed the main stuff, and last I just want to show you like how to give an open source contribution. Okay, how to give an open source contribution. That is the last thing that I am planning to discuss. And before that, two small topics. Like here there is an option called issues. Okay, so if your code is private or public, if someone want to report an issue, they can do that. For example, bug found. Okay, you can give a title and a bug on rows object detection node. Okay, so if someone report an issue, okay, you can find the issue here. Okay, and then you can solve it, and then you can close this issue. Okay, so that is one method. There are multiple methods like give a pull request, all that, but I just mentioned the issues option in the GitHub. Okay, this is for like if you are working with some open source project, if you want to report a bug, you can use the issue. Okay, and if you want to raise a pull request, you can do here, create a pull request, and this is a main branch and this is a feature branch. Okay, so you are going to merge from feature to main. Okay, so you can just compare and then add the pull request. Okay, and next is the action. Okay, so this is another big topic called continuous integration. Maybe I can easily show you with an example. Okay, what is this continuous integration? You might see this thing in most of the repositories. Let me see. Okay, it's not here. Maybe default. Okay, maybe you can take this. So how many of you see this thing, this badge in repository, GitHub repositories? Is anyone saw these repositories before? Saw this badge before? This kind of badge like CI passing, documentation, CI passing. Anyone see this badge before, guys? Anyone observe this before? Okay, so this is again an important stuff. Like for example, Git actually gives a feature called Git Actions. Okay, Git Actions. So what is Git Action? It's nothing but if you want to build your code in the GitHub in an environment. Okay, for example, if you create a rows noitic package, and if you want to build that rows noitic package in a noitic environment, Ubuntu noitic environment, you can do that. Okay, so that is actually the Git action. So Git action, you can mention there is a configuration file, and inside that you can mention in which environment that you have to test this code. So whenever you push anything on this branch, okay, then what happening is that it will be taken out to build. Okay, it will be automatically built, and then the result will be updated in this branch. Okay, so I can show you an example for maybe Google Cartographer. Google Cartographer rows. GitHub. Yeah. So if you check this repository called Google Cartographer, you can see the build is failing. Okay, but documentation is passing. Okay, so for this actually we have to like mention some configuration file like this. Okay, that you can, I mean, these will be covering in our course actually, how to write a configuration file for automatically build the repository. So this badge is actually an indication like whether this software is building properly on this environment. Okay, so if you put a badge, it will be useful for others. It is an assurance like this code will be working on Rosnoiting. Okay, that is called the continuous integration. So if you just I mean search about CI/CD, you can find it's actually the continuous integration and continuous delivery, which is like whenever we update a code, it will be automatically build and then it will deploy like that. Okay, so this is actually using in most of the companies. Okay, so that is the Git actions. Okay, Git action. Let me take the yeah. And then projects. So I think you can include one repository in a main project. Okay, so that is this project. I'm not using this much. I think it's a new feature. Then security, I think that you can mention some security feature. I'm not using it. Insight also, like I'm not using. Like settings, I think you can, because you can configure all this stuff on settings. Okay, and okay, so now I can show you how to give a open source contribution. Okay, for example, if I just want to contribute to Cartographer. Okay, so first what I will do is I will fork it. Okay, I will fork to my GitHub profile. Okay, so if you fork it, you will get a copy of the Cartographer on your profile. Okay, then what you have to do is you have to create a local copy of Cartographer. So just go to the terminal and just clone the Cartographer repository, which is in the RoboAcademy profile. Okay, so currently we have the Cartographer package locally. Okay, so this is a Cartographer, and then you can see the master branch. Okay, master branch. So what you have to do is you have to create a branch, maybe called feature branch. Okay, feature. Okay, and then you can modify something. Okay, you can modify, like you can just modify authors. Okay, just authors. Then I'm just adding Lyndon Joseph in the authors. Okay, so currently we are in the feature branch and we have changed the authors. Okay, so you will get it using git diff. Okay, so git diff is this. Okay, so now what I'm doing is I'm just adding this file, okay, called authors. Then I'm committing it, changed authors. Then I am pushing this into feature one. Okay. Okay. So you can see permission to RoboAcademy is denied to deploy the key, because in this repository there is no key given. Okay, I didn't added the deploy keys here. Okay, so I have to add the keys. Okay, then only I can use the SSH mode. Okay, so simply copy the key, like gedit /home robot.ssh then idrsa.pub. Okay, So this is a key, just copy paste and then copy here, then allow write access, add key. Okay, so give the password. Okay, oh, key is already in use. So what I will do is I will delete that key from the other repository, this one. Okay, I'm deleting it and then I'm deploying it. I think we can add keys in each repository, or you can create a common key for all repositories. Currently, I think I have configured for individual repositories. So if we have multiple keys, I think there is an issue. Okay, so if I after adding the key, if I push it, it will work. Okay, so currently I can just show you the cartographer copy, and what we did was we created a feature called feature 1. Okay, feature 1, and that is actually in the RoboAcademy. Okay, so in order to give a pull request to the actual repository, okay, so that is the actual contribution, open source contribution. So you can do the compare and pull request, and then you can see here you can select the base repository. Okay, that is the actual repository, or the RoboAcademy cartographer. Okay, so in order to give a pull request to the actual repository, you can select the cartographer, and then you can select the branch. Okay, that is a feature branch. Okay, so we are actually trying to merge the RoboAcademy cartographer feature 1 branch to the base repository master branch. Okay, now you have to build you have to add this and then press create pull request. Okay, you have to click pull request. Then what happening is that this pull request can be visible on the actual repository. Okay, I'm not merging it. Okay, it will be visible in the actual repository. Okay, so you can see a list of pull requests here. Okay, so these all are all features maybe. Okay, but they didn't merge it. Okay, it's all not merged, it's simply available. Okay, so that's how we are give a an open source contribution. Okay, like we have the copy of the project, and then we are giving a pull request to each thing. Make sure that is a sensible pull request, otherwise they will not accept it. Okay, but you can start doing this to build a strong open source contribution portfolio. Okay, so that is actually a good thing. Okay, so I'm just deleting this repository. Okay, so I have deleted. Okay, and I'm deleting the rows object detection. Okay, so these are the things that we have to discuss on Git. Okay, I'm not saying I have discussed all the things, but the important stuff that we require. Okay, okay, so now I'm just switching to another topic. Okay, I will use maybe 15 minutes, 15, for the next topic. Then I think we can discuss after this week. Okay, yes, so I'm just closing it, and let's start with Docker. So how many of you already worked with Docker before? Docker, anyone worked with Docker before? Anyone worked with Docker, guys? Okay, okay. I think you didn't work with Docker. Maybe it may be a new topic for you. Uh, Maybe I can show you. Okay. Okay. So again, I am um, taking the DevOps thing. Okay. Yeah, maybe the last diagram was good. Okay. Yeah, this is okay. DevOps block diagram. Um, okay. Let me check. DevOps Docker. Yeah, I think you can we can go with it. Okay. So DevOps, Docker, all these terms are connected, but I just want to talk about Docker in specific. So do you have this situation like you have created a software on your computer, okay? Then you have to deploy the same software in another computer, okay? Like you created a software on your computer and then you're going to run the same thing on another computer, okay? So what are the problems? What can happen when you create and when you deploy this software in another computer? What are the problems can happen? Is anyone tried this thing like putting one software in another machine? Anyone have experience in that? Okay, okay, then that's fine. That's fine. The thing is that while working with robots, okay, not only robots but in any application, in any software, we will have we will be working on local machines, right? Local machines, and you will be developing an application. Okay, consider it's a big application, and then you are going to deploy it on another machine. Okay, you are deploying on another machine. So one of the difficult thing while deploying an application on another machine is meeting the dependencies. Okay, meeting the dependencies. For example, I have written a ROS package or ROS application. That application is doing object detection. Okay, that application is doing object detection, and in order to run that object detection, you need ROS, you need OpenCV, you need PCL. Okay, so these things are called the dependencies. Okay, so even if you create the application on your computer and if it is working on your computer, it will not work in my computer. If you give that code to me, then what I have to do is I have to set all these dependencies. Okay, then run your application. Okay, so there are several ways to avoid this thing. I mean the dependency issue. I hope you are aware of the virtual machines. Okay, virtual machine. So what is virtual machine? The virtual machine are literally a guest operating system in which you can create application, and then if you want to run the same virtual machine on another computer, you can simply copy the files. Okay, the virtual hard disk, and you can simply copy the file into another computer and run using VMware. Okay, that is possible. But what is the disadvantage of virtual machine? What is the disadvantage? Do you think about the disadvantage of virtual machine? Actually, there are some disadvantages. Okay, the disadvantages are like in a virtual machine, it is having the complete operating system. Okay, for example, if you run an object detect application in virtual machine, Do you need Firefox for that? No, obviously no. And do you need another application like LibreOffice or something? No, right? So if you include all these application on your virtual machine, then in order to deploy a small application, that is object detection, on another computer, you have to carry a 30 GB file or 35 GB file. Okay, so that is actually tedious. Like you have to copy all this stuff into another computer and you have to run it. That is one problem. And the next problem is the resource usage. Okay, so if you want to only run the object detection application, do you want to run the desktop environment? No, right? You don't need actually, right? You don't need other things like the background applications and all. You don't need. Okay, so if you are using a virtual box for this application, you are actually wasting resources and also the storage. Okay, but what is advantage of using virtual machine? It's actually very easy, right? Like working with VMware and VirtualBox is pretty easy. Okay, so in order to solve this problem, there is another software called Docker introduced. Okay, Docker. So what is Docker? Docker is actually very similar to the VirtualBox or like VMware. Okay, the virtualization software. Okay, that we already have. Okay, so the difference is you can see here. Okay, Docker is an open source application. Okay, so what is Docker? What is it's using is it can specifically deploy an application, a specific application, only that. Okay, for example, if you want to deploy a object detection, you can specifically deploy that object detection with necessary dependencies and necessary resources. Okay, so we are saving the storage, we are saving the resources. Okay, and everything, you are saving the bandwidth, a lot of things. Okay, so that is what the main difference between a virtual machine and Docker. Okay, I think you heard about the word Docker. Okay, Docker. The meaning of the Docker. Maybe from the image itself. This is a logo of Docker. So you can find a whale, and on the top you can find the containers. I hope you have seen the actual containers, right? Containers, ship. You have seen these containers, right? I hope you have. Maybe I can show you that. Just a second. Yeah. Oh, it's not having much clarity. Yeah, this is having. So this is a ship carrying a lot of containers. Okay, and what is inside the container? It may be a specific thing, like it can be some raw materials for producing something. Okay, and by using containers, there is no mixing up of the things, like the raw materials for maybe some electronic gadget, maybe in one containers. Okay, and all the containers are carrying by a ship. Okay, so there is a ship, and on the ship we can put a lot of containers, and each containers are safe, and it can able to exist in the ship. Okay, like that, if you check the Docker logo, you can find there is a whale. Instead of ship, there is a whale, and on the top of the whale there is a containers. Okay, so the Docker containers are the software containers. Okay, it's actually, we can call it as, I mean, the word is actually containers. The containers will have the necessary dependency for working with an application. Okay, so this container will have the application and its dependencies. Okay, so that is actually Docker. Using Docker, you can create a container, okay, which is having your application and dependencies, and you can run it, okay, and you will get the output. For example, if you run the object detection container, the object detection will be run, and then you will get the result. Only that. Okay, so this is the main purpose of Docker, and why it is using. I can say an example. You have created an application and robotics application, and then you have to deploy it. Okay, so in order to deploy a robotics application, you have to meet a lot of dependencies, right? Using Docker, you can install all these dependencies. You can mention all these dependencies in a file called Docker file. Okay, and then anyone can build a container, okay, or image using that Docker file. Okay, maybe I can just show you just a second. I will explain the importance of Docker in ROS as well. Okay, ROS now take, yeah. So you can find a Docker file like make file. You have seen the make file, right? So this is a file. Currently you will not get anything, okay, you will not understand, but what it is like, it is a file having all the dependencies and the application as well. Okay, so if you want to work with ROS Noetic, move it. Okay, if you want ROS Noetic for your application, then you can use this Docker file. Okay, so if you want to build a container of this, you can use this command in order to build this Docker file, and then you will get a container which is having ROS and ROS Noetic. Okay, so using Docker, you can work with ROS Kinetic, Noetic, I mean any versions. Okay, so there are many advantages while working with Docker and ROS. Okay, you can easily work with different distribution, and yeah, so these are the things. Okay, these are the things. I will get back to that in detail, but just understand that Docker is very similar to the virtual machine. The only difference is that the main difference is that it's mainly designed for an application, a single application. Okay, and there are main difference between a virtual machine and Docker. Like the virtual machine is actually using, maybe it will be better to show with some block diagram, virtual machine versus Docker. Yeah, I think this will be good. Yeah, from this you will get an idea. Okay, so here on the right side there is a virtual machine, and left side there is Docker. Okay, so on the bottom side you can see the infrastructure, meaning the hardware. Okay, the CPU, RAM, storage, and everything. And on the virtual machine that we are working currently, there is another layer called operating system, like this. Okay, so on the top of infrastructure we have an operating system, and on the top of operating system we have a software called hypervisor. Okay, hypervisor. So if you just search for hypervisor, you will get many details. Okay, so the hypervisor, so I can explain what is hypervisor is, and on the top of the hypervisor the virtual machines are running. Okay, so hypervisor are like a software which is allocating resource for each guest operating system. Okay, so the hypervisor is the main program that is like managing all these guest operating system. Okay, the problem is if you want to deploy an application, you have to install the full guest operating system. Okay, then only you can install an app. Okay, so it is taking lot of CPU and memory and also the storage. Okay, but in Docker it's actually different. So Docker is having a Docker engine. Okay, so that Docker engine is tied to the operating system. For example, the Docker can work perfectly on Linux. Okay, Linux kernel. So the Docker engine is very close to the Linux kernel. It's actually I mean binded to the Linux kernel, and on the top of this Docker engine we can deploy each application. Okay, so each application is sharing the resource of the infrastructure, or the CPU, RAM, and all. Okay, but it doesn't need a full guest operating system. Okay, so that is the advantage of working with Docker. Okay, so I'm just pausing it now, but I'm just sharing the links of that Docker that we are following. Okay, so just understand that Docker is a platform or a software for deploying or packaging your application. Okay, yeah, so it's actually an important tool while working with rows. Okay, so next class we will be starting with Docker. Maybe I think I need maybe one class for that, and after that we will be starting with this portfolio stuff. Okay, that will not take much time. Okay, yeah, and yeah, so that is a plan. So if you have any question you can ask regarding the Docker and GitHub, you can ask. So let's conclude with GitHub, and I think you got a basic idea of Docker. So next class we will be continuing with Docker and then the portfolio stuff. Okay, so let me know if you have any question regarding Docker and Git. Any question, guys? Any questions? So this is official website of Docker, which is an open source. Docker is an open source and there are millions of users. And the advantage of learning rows along with the dependencies or the prerequisites are each topic that we are discussing, like the Git, Docker, then OpenCV, each thing is a big topic. Okay, so you will get an opportunity, the job opportunity in individual fields. If you know Docker, then you can be in IT field. There are a lot of opportunity for Docker engineers. Okay, so each topic is vast, so you will be like you know almost all these things, but may not be an expert, but at least you know what is happening. Okay, so yes, so these are the things. So if you don't have any doubts, maybe we can discuss the Docker main topics of Docker maybe in next class. Okay, and if you have any question you can share it in RDLP discussion or something. Okay, yes, so that's it, guys. We can conclude today's session. Thanks for attending. So see you next week, and if you have any doubt, let me know. Okay, then, bye everyone. Good night.